Alrighty then. I think it's about time we fire up yet another lovely stream on mass balances. So I'm just gonna jump straight into it. I have added another part to this, stream, lecture, whatever we want to call it. And that is because I just want to make it clear why it's so important that we upgrade from solving mass balances by hand or sequentially and doing them simultaneously. So I know that I showed some of my students this lovely example here where we have an extremely simple system with some golf balls entering into a tower. Some of them go out the top, 10% go out the bottom. Then we have a split where we recycle 90% and then it just continues moving on. Now, if we didn't have the recycle, this would be so easy. 100 golf balls enters, 10 of them goes out the bottom, 90 goes out the top. The system is now in balance. The problem is when we start to have this recycle, the 10% is not based off of the feed, it's based off of how much is actually in this tower. And I actually tried to set it up in a lovely document called Thomas Hates Us, because of course I do, that's the way it is. And I have set up a simple mass balance, so I have my system and recycler, and then I have the two extra rules. 90% is recycled and 10% of the total amount in this tower gets thrown out the bottom. And when I solve this or these equations, I can easily get these results. And as we can see in my solver settings, I basically set it up like we normally do. Actually, I think I forgot to change. Let's just turn my lovely screen into grandmother mode so it'll be a bit easier to see on stream what's going on. There we go. Nice and massive things. Oh, it looks horrible in real life. But the thing is, some of you might say, well, can't we just do it by hand? Can't we just take it step by step? And the thing is, technically you can. So for instance, over here, I've started to set it up. So I said the first step or the first time I send in 100 golf balls, I have 100 in my feed, 90 goes out the top, 10 goes out the bottom. And then I can easily calculate, well, if 90 goes out the top here, 90% is recycled. So I just take 90% of that. That's what's recycled. And of course, the rest goes to my product. Now, the next time I send in 100 golf balls, I say, okay, I'm going to add 100 balls in the feed. In my bottom stream, I'm going to take 10% of what's inside of this tower. Now, that would be my new feed of 100 and the recycled stream of 81. So that means I'm now sending 18.1 balls out the bottom of this system. And similarly, I can calculate, well, if I take all of the balls, subtract the ones that went out the bottom, the rest must exit in the top. And then I can calculate again and say, okay, how many go through my recycle stream, how many go to my product, and then I can start all over again, because as you can see, my recycle stream from here to here has increased. So the next step, I'm gonna have even more balls in my system, and it just keeps going. So how bad can it get? Well, I made the slight effort of actually trying to calculate this. So every time we go one step, that's another 100 golf balls we are feeding into our system, and we just keep going until down here I put in my total mass balance. So that's how many balls are in the feed, how many are in the product stream up here, and in the product stream down here. And of course, we know that if a mass balance is matched up, this should give us 0. You can also see here, this is the number of steps, so the number of times I have to do calculations. And when I was doing it, I figured out I was doing 4 manual calculations each time. So how many times do I have to repeat it? Well, we need actually we can just look. This is my total mass balance, so we need to be sort of in the area of 10 to the minus 12. So we start here, and then we start going and going and going. 6, 7, 8, 9, 10, 11, something around here. So now we're sort of getting to the same ballpark precision as what I had with the way I solved the mass balance. So yeah, somewhere around 580 or 6,000 calculations in order to get the same level of precision. Now, we don't want to do 6,000 calculations each time manually. We want to somehow make it automatic. So that's why when we start to get into recycles and bypass streams, it becomes so much more difficult to deal with without using Excel and solving all of the equations simultaneously. So normally we could say, you know, what is the value of, let's say, the top stream here? Well, that would be this stream plus this stream minus that stream gives me this stream. Unfortunately, this stream will depend on this stream, and then I have this circular loop. So it's also very easy if you try to do it like non-systematically in Excel. It's very, very easy to get circular references where Excel just goes, you can't do that. You can't say that you want to calculate stream 2 based off the value of stream 4, and you want to calculate stream 4 based off the value of stream 2. That's just not possible. So as an example here, let's just shrink this down a bit so we can see what's happening. We'll chuck it over here. So I just have my feed stream, my top stream, recycle stream, my product stream up in the top, and my bottom stream. All of those masses, all of those numbers of balls are unknown. And I just jump. Can we do that? Yeah. I just start out here. I do my, let me just check, is this my system balance? I might actually have done it for, yeah, so this is for my tower, so for this box in the middle, and I say stream 1 and stream recycle go into this, so B2 and B4, minus the two streams exiting, that one and this one, so that would be my top stream and my bottom stream. So this was my tower balance. The next one here is my recycler balance. And then I have two bonus equations. One is that 90% has to be sent back here. So I just take my top stream, multiply it by 90%, subtract the mass that I find down here. If that holds true, if I'm recycling 90%, that should give me 0. And finally, I do for the 10%, I simply say I have my feed, I have my recycle stream. If I add those two up and what's it called? What the hell? Subtract the bottom one, then that should end up giving me the desired values. And then I just solve it. So that's how you would set this up. But I just included this to remind you that we don't want to run around in circles. We want to do this automatically. We want to have Excel go through all of these iterative calculations for us. And now we can start to look at one of the actual assignments that I suggested for today. So we're going to start with this distillation tower. In this case, we have two streams that are going into our tower, and we also have 3 streams exiting our tower. You can have this in real. This is not just made up. Many distillation towers have multiple feeds or multiple product streams. So when we do it, for instance, with in petrochemical production, so if we want to make diesel and gasoline and all of this, we can, for instance, take some mixture of crude oils and we can distill it into different fractions. So that would be the different types of fuel we get. So not an uncommon thing to see. In this case, we have 3 components, A, B, and C, and we have various information. In some of the streams we know the masses, in some of the streams we know something about compositions, and so on. Now, if you do a degree of freedom analysis of this one, we will actually end up with a problem. Let's see, can we draw something? Actually, I think I put it over here, so I just need my lovely Remarkable, not a sponsor, but very happy with it. And wakey. Let's see if I can get to draw. No, there we go. Here we go. So this is basically the system we're looking at. And if we look at how many unknowns we have, so right off the bat, I don't know the mass of that one. I don't know. So down here I have two compositions. One of them I'm going to ignore. The other one will count as an unknown. And what else? I have my total mass up here. I have one of my compositions here. And I have a mass down there. So for these two compositions, the one here, I use this trick that they have to sum up to 100%. So that's why I removed them as being unknowns. So that gives me 5 unknowns, and I have to figure out how many equations I can set up. Well, I only have one unit operation with 3 components, so that means I can set up 3 independent mass balances. 5 unknowns and only 3 equations and no other bonus information. Then I have to say that system is not defined. Like I am allowed to pick values for some of these unknowns. I can sort of tweak my system to fit it. But degrees of freedom in this case, we had 5 unknowns. We could set up 3 mass balance equations. So that gives us 2 degrees of freedom. So in order to solve this, we either need to find 2 more equations we can set up, or we need to get some information or assume some information for some of these variables. So here I have an example. I happen to know that these values should work. So that's the thing you might not be aware of, is even though we say that we can sort of pick the desired unknowns, there are limits. So for instance, there's only one place that A enters into my system, and that's here. That's the only place where I see A coming into my system. And I have a defined amount, so 70% of the 1200 exiting here. So for instance, if I said that the mass up here, M3, if I set that to 7,000, that would never be possible. The absolute maximum amount of A I can get into my system is 5,300 kilograms, and I'm already losing some of it in this stream. So I can't even have 5,300 up here. That would not be technically possible. So you have to be a bit careful if you're dealing with stuff like this. That's also why we try to give you systems with 0 degrees of freedom, because then there should only be one possible solution. But let's take this lovely thing. Let's see if I can grab it. And we're going to chuck it into Excel. I think I set up a lovely little example for it. Yeah. So I already put up the different streams that I have, and we just have to fill in the different values. So for instance, in our top stream, stream 1 here, there's no A, 3% of B, 97% of C. For stream 2, I know that there's no C, and I'm gonna say B is just 1 minus whatever A ends up being. That's gonna be an unknown. Total masses, can I just move that a bit? Total mass of stream 1, no idea what it is. Mass of stream 2, 5,300. If I look at stream 3, I don't know the mass that I'll have up there, but I do know that it's gonna be only A. In stream 4, I know my mass. I know I have 70% of A. That means I have no idea what B might be, but the composition of C, or the percentage of C, 1 minus the sum of the two others. There we go. And for stream 5, scroll down a bit. I don't know what the mass is, but I know the compositions. So unknown mass, what was it? 60% of B. 60% of B, 40% of C, no A, check. So that's basically the information that I have. 5 unknowns, and over here I can calculate just like I normally do. That one times the percentage. Fill right and down, and I then had some values I wanted to put in because I said I have too little information. I just need to check. M1 is 500 kilograms and that one is 0.8. So 0.8, 500 kilograms. Was it M1? Yeah. So that means this one is no longer an unknown. I've decided what I want it to be. And here I've decided what I want it to be. 3 unknowns, and I said I could set up 3 equations. So let's try. So I'm gonna look at my unit, and actually let's just move that over here. And I'm just gonna say for my total mass, what goes into my system, that's stream 1 and 2. Stream 1 plus stream 2. What goes out? All of the others. 3 plus 4 plus 5. There we go. And I can fill that to the right. That gives me 4 equations. I'm only allowed to use 3 of them. The last one will not be independent of the others. So 3 equations. Let's see if we can set that up in Solver. And I basically say the first equation, value of 0. The 2 other equations, value of 0. And I'm allowed to change all those 3. And I can't remember if it messes up. No, it looks fine. Solver found a solution. And does it look reasonable? Positive masses, percentages looks fine. Everything is close to 0. Yep, I have now solved this system. So yeah, the system can be solved. The next one, we will take a look at how I set it up when I have this recycle stream. So this was the air conditioning, where we have some wet air entering. We want to dry the air, and we want to deliver 100 moles per hour to our customer or to our room. So we have one unit operation that just mixes a couple of streams. We have a unit operation that removes some water. And then we have a split where we basically take this stream and split it into 2. These 3 streams all have the same concentrations. So we have to be careful of that when we are setting up our equations. But we're basically just gonna put that into Excel. I think I had it ready here as well. Yes. So we're gonna start by putting in the information. 96% dry air. Actually, because I only have 2 components, I can just do this all over the place. 96%, 97.7. Then I have my stream 2.1, 983. Stream 2.2 only contains water. Oh, I did it wrong. Hang on. 1 minus that one. There we go. There we go. So all of these I just calculate by taking 1 minus the other concentrations. 3.1 is 0.983, 0.983. That should check out. Total number of moles for all of these, no idea. I know I have 100 there, and I know I don't know what will be there. And finally, calculating the different component amounts. Fill right and down. There we go. And now I want to start to set up the different equations that is possible for this system. So I'm going to do it systematically and say I have for my total system unit 1, unit 2, unit 3. And for all of those, I could set up a total, a dry air, and a water balance. So let's look at our total system. So we're going to put in our magical square, if I can remember where it is. There we go. So we're going to put in our magical square and say if I'm only looking at the entire system, all I know is that stream 01 comes in, and that's stream 22. And, let me do it like I normally do. Stream 22 and stream 31 exits. Okay, that would be my total balance. Then we look at our first unit operation. What do we know about this one? Well, I know that, where was it? I know that stream 01 goes into it. I also know that 32 goes back into it. And I know that stream 11 exits it. So stream 01 plus 32 minus 11. That's my balance for that one. We move to unit 2. What do we know about that? Well, in my unit 2, I know that stream 11 goes in. I know that stream 22, keep doing it wrong, stream 22 and 21 exit, and that's all I know about that. And for my final here, well, I know that, what is that? Stream 21 goes into the system there, and stream 31 and 32 exited. Again, questions, just ask in chat. I'm trying to keep an eye on it. But I've now written all of the lovely mass balance equations that I can. Gonna fill them to the right. And now we start to get into where we have to decide what things do we want to remove, what equations do we want to remove. This time, because I've looked ahead a bit, I'm gonna remove my system balance. We're gonna remove our water balance here and say these are not independent of all of the others. That would normally be sufficient. However, for this, our unit operation 3, the concentration that goes in and the two that come out, the concentrations, the compositions are the same for all of them. So that means only one of these 3 equations are independent of all of the others. And you might say, hey, hang on, why is that? Why is it that suddenly we have to do it like that? So, come on. Where did my remarkable go? There it is. Oh no! I lost synchronization. What a horrible thing to happen. Let's do my quick sheets. And I want to share. There we go. Perfect. I will try to remember not to close it down again. So, why is it that when I have a system where I, for instance, just have this one, I have one stream coming in, and then 2 streams going out, and I have the same concentrations everywhere. So let's say we have XA, XB, and let's, just to make it easy, let's say it's 60% and 40%, then A and B in the 2 others is also 60%, 40%, 60%, 40%. Stream 1, 2, 3. So why is it that suddenly I only have one independent equation? Well, what I can do is I can write up the equation or the total mass balance for this system. So the total mass balance for this system would just be stream 1 is equal to stream 2 plus stream 3. Okay? Now, if I then want to do my component A balance, well, all I have to do is take all of these and multiply them with the concentration of A, which in this case means I multiply everything by 0.6. So that means I'm taking one equation and just scaling it to a different size. That means it's not independent. It's like when I know in class I often say, well, if I have x plus y is equal to 10, and I ask you to solve it, many of you will say, well, we can't. We have two unknowns and only one equation. We need another equation. And I go, yeah, sure, I'll give you another equation. 2x plus 2y is equal to 20. And you go, no, that's not the type of equation we need, because this is just the first equation, everything multiplied by 2. So when the compositions in all of the streams are identical, then we have this issue that all of our mass balances are dependent on each other. We can only use one of them. So that's what we'll do in this case. We jump back to the Excel and we say, okay, I'm only using one of those. I can use those 4. So I have 5 equations. Let's hope 1, 2, 3, 4, 5 unknowns, exactly what I want. So again, data and solver, and just like we did before, I want this one to be 0. I want my other 4 equations here to have a value of 0, and I want Excel to change the values in all of the lovely yellow cells. Solve it. Excel found a solution. Everyone's happy. We just check. All of my values, all of my equations trend toward 0. All of my masses are positive. Looks reasonable. Yep, I have now solved another one where I have this recycle stream. Where's my recycle stream? So one thing you should also notice is if you look at our recycle stream, I'm recycling 290 moles. So in this tube or in this pipe, I have 290 moles flowing every hour. But in my feed stream over here, in stream 01, I'm only putting in 102 moles. So that is how we have this buildup of material over time, that when I turn this air condition unit on, I won't reach this lovely balance to start with. I have to nurse it into this steady state. But once I reach a point where I have 290 moles available flowing here, then I can have a steady state where I send in 102 moles here, take out approximately 2 moles here, and deliver 100 moles to the room. So that means even though I'm only sending in 102 moles, I can have pipes in my system that at steady state will move around way more material. So you have to be a bit careful about that as well. So that means I mean, it might seem counterintuitive, but that means I need larger pipes in part of my system than in the pipes that are actually feeding material or removing material from my system. But that was the air conditioning one. Which one did I have envisioned next? Let's see. Oh dear. So this is time for me to sit down. Oh, that might be noisy. Actually, let's just take a short break. I'm gonna sit down and then we'll continue. Hopefully you're joining me there. Yeah, comfortable enough. There we go. Okay, so this one we have not done in class, so let's have a look at what the text says. So this is a simple extraction where I want to send in some beans, where I want to extract some oil from them, and I want to use, I think it's hexane. Yes, I want to use hexane in order to extract the oils from those beans. I lead that mixture onto my filter, and in that filter I'm gonna remove, I'm gonna remove some filter cakes or some solid materials and finally, I want to take all of my hexane that I've paid a lot of money for. I want to evaporate it, reuse it, and have this cycle going, and hopefully have completely pure oil exiting. Now we're getting a lot of bonus informations in this one, but we're gonna try and set it up. So we'll start just with the drawing and the information we have from the drawing. And as you can see here, I have decided to name the different streams, not stream 1, 2, 3, 4, but basically what they are. So for instance, I have my stream of fresh hexane. So hopefully, since I'm paying for it, hopefully that's gonna be pure hexane. In the feed into my extractor, again, I would hope that that's just pure hexane. Let's just crop that a bit. There we go. Then I have my beans, and then I need the information about my beans. So let's go back to the assignment, read what does it say about the beans. Actually, I'm just gonna do like this, so now I can see it and you can't, haha. So my beans would contain 13% oil, and the rest would be solids. So 1 minus the 13%, there's no hexane in my beans. Then I mix it all together. At that point, I don't know what the compositions are. So I'm gonna say no idea for those two. The final one, 1 minus the sum of the others, like we normally do. In my filter cake, do I know anything about that? Let's have a look. I know that my filter cake contains 70% solids. So that means this must be equal to 1 minus the sum of the two others. But that also means that this one, I don't know right now. No idea what it is. After my filter, hopefully I've been able to remove all of the solids. So that means I only have one unknown, and that would be, I'm just gonna pick the oil as being my unknown here. And finally, over here, I want pure oil exiting that stream, and I want pure hexane in my recycle stream. So that's what I'm being told in terms of compositions. Then I start to look at what do I know in terms of the masses that I might want to send into this. And I need to figure out how much hexane I need if I want to process 500 kilograms of beans. So we jump over here, find our bean stream, and we say that needs to contain 500 kilograms. Do we know anything else? We don't know anything else about masses, so for now we're just gonna say these are unknowns, these are unknowns, and all of these I want to calculate by multiplying percentage with total mass, fill right and down, and then we have to start setting up our mass balances. Oh, this is gonna be tricky. Let's see if I can make this a bit smaller. Hopefully you can still see what's going on. But in this case, I would be able to set up a balance for my mix point here, for my extractor, for my filter and my evaporator, and for my entire system. So let us do that. We have our system, we have our mix, we have our extractor, we have our filter, and we have our evaporator. And for all of those, I could set up balances for the total mass, for the oil, solids, or hexane. We're just gonna focus on the total for now. Anything in chat? Nope, everything's fine. Total. Let's look here. I have one stream entering, that's my fresh hexane. So that's that one, fresh hexane. I have beans entering, so where's my bean stream? That's there. And what streams do I have that are exiting? I have two streams. I have my filter cake, that's the cake stream, and I have my oil stream. Those two should exit my system. That's the balance for the entire system. For my mix point here, I have my fresh feed entering. I have my recycle stream, so the one that goes here has to go in there as well. And finally, I want to subtract what I call my feed. So that's my feed to my extractor. There we go. Balance for the extractor. Well, my feed stream enters, my bean stream enters, and my, hang on, why did I call that mix? Yeah, what can we call that? Let's call it I can't spell now. Extract. There we go. And did I do that right? That plus that minus that. Yes. For my filter, I have my extract stream entering, and I have my cake and my filtrate exiting. For my evaporator, I have my filtrate entering, and I have my oil and my recycle stream exiting. And these I can fill to the right. So before we go over there, how many unknowns do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I count 11 unknowns. And then we need to look at how many different equations we can use. So like normally, we're gonna remove, where is it? There, we're gonna remove one row. We're gonna remove one column. And then we start to look at what is possible. For my mix point here, it's pure hexane in all of the streams. So we have the exact same problem as in the last assignment, same concentration, pure hexane. So I can only use one of my equations. Oh, no. So there, in my extractor, I can use all of them. In my filtrate, I can use all of them. In my evaporator, well, in my evaporator, I have another problem, and that is that I don't have any solids present, right? So I can't use this one either. I'm just going to remove that. It's going to be fine because it's going to be 0 no matter what I do. But just to do it correctly, I'm going to remove that as well. No solids in this part of the system. Making a solids balance doesn't make sense. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right now I have 9 equations, leaving me with 2 degrees of freedom. I need to find some extra information. So I go back to the description and I say, okay, what information have I not used? Well, for instance, I know that the ratio in the feed to the extractor here is 3 kilograms of hexane for every kilogram of beans. So let's try and put that. Actually, can we copy that? Let's try. Let's try and see if we can put this into an equation. So that's gonna be my bonus 1. So how do we do this? Well, basically it means that if I take my mass of beans and multiply it by 3, I need 3 times as much hexane. So if I take the mass of my beans and multiply it by 3, and I subtract the amount of hexane that is, let's make sure it's the right one, fed into my extractor, if that gives me 0, then I am happy. We can just test it here. So I know I have 500 kilograms, so I know that if I have 1,500 kilograms of hexane, that equation should give me 0. It does. Perfect. I wrote it correctly. Yay! I'm now down to 1 degree of freedom. Let's move that down here. We use this to get here. And then we need another information. What other information do we have? Here. The stream of filter cake is wetted with a mix of oil and hexane, and analysis shows contains 75 weight % solids, balanced bean and oil hexane, and those two have to be in the same ratio as the stream exiting over here. Okay, how do we set that up? Well, we can look, where is it? Bonus 2. So, what is the ratio of oil to hexane in this outcoming stream? Well, that would be the mass of oil in my filtrate in relation to the amount of hexane, and I want to compare it to the ratio in my filter cake. So I just want to subtract, and we go to my cake and say I want the oil over hexane in that one. And Excel gets very unhappy and says you're not allowed to divide by 0. Luckily we can solve that. We put in some dummy values, so these are not incorrect value, or sorry, these are incorrect values. I'm putting in values that are in the area of what could make sense. So it would be somewhere between 0 and 1 for the percentages. I have 500 kilograms, so I'm just guessing ballpark it's gonna be that sort of area. Okay, that's just to avoid having the error that it divided with 0. So now I have 2 bonus equations that hopefully gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 unknowns, 11 equations, 0 degrees of freedom. I should be able to solve it using Solver. And how am I gonna do this easily? I am gonna ask Solver to set that equation to a value of 0, set all of those equations to a value of 0, set all of those equations to a value of 0, and set that one to a value of 0. So all of the equations that are not colored red have to give me 0, and Excel can change all of the lovely cells over here, and fingers crossed, might not work. I know this one can be a bit tricky for Excel to get right. Oh dear, it's taking a long time. Solver found a solution. Are we happy with the solution? Let's see. All of my equations give me close to 0. The masses, they are all positive. The percentages all look fine. So at this point I can say I've now solved the system of equations. I was asked, what was the question? How much fresh hexane must be supplied? And we just go to our fresh and say, well, I need to supply 138.9, so 139 kilograms of hexane for every, I think was it on an hour basis or day basis? Day basis. So every day I need to buy 139 kilograms of fresh hexane, and it will leave me with 59 kilograms of oil. So that's how you would approach this. Again, I mean, it's the exact same thing I'm doing over and over. I'm using the same principles, setting up the equations, setting up Solver the same way every time. And all the way through, I'm making degree of freedom analysis, looking, saying, do I have enough equations? Do I need to look for more equations? Finally, we have one of the homework assignments. So assignment C, the orange concentrate where we had a bypass. So we take some of our juice and we send it past one of our unit operations in order to just keep track of what we're working with. Let's just draw a little sketch, and I need to be able to read the assignment while we do. But in this case, we basically have some fresh orange juice and we want to create a concentrate. We want to remove some water. The way we're going to do that is we're going to send in our fresh orange juice. We're going to, I would actually prefer to send that the other way. We're going to bypass some of the juice. The other juice we're going to send to an evaporator where we're going to remove some water. And finally, we're going to mix it back together. And then we have whatever comes out here. Now, the informations that we are being given, we would like to use 200 kilograms of fresh juice. 200 kilograms. And we also know that if we look at the solids over here, they will be 12%. The percentage of water is going to be the balance, 88%. And because we are just bypassing, we're not changing anything here, it's just a simple splitter of the stream. So that means the concentrations over here for solids and water are going to be 12 and 88%. The same for the bottom one. It's going to be solids and water, 12%, 88%. For the water stream where I want to remove my water, well, that's going to be pure water. For my extract over here, I'm being told in the assignment that the percentage of solids in this stream is 58%. Whoop. That leaves me with composition of water of 42%. And finally, my product that I want to sell to my customer, it has to have a solids percentage of 42%, amount of solids. 42% amount of water would be 58%. So that's the system I want to try and see if I can set up in Excel. I am not being given any other information than that. So let's just grab that artwork, see if this actually ends up working. Where was my Excel? And again, I've cheated and set up part of the Excel sheet ahead of time. So we're going to start to fill out the information. I know that I have 12% solids. And for the water, I'm just going to take 1 minus the other percentages. In my bypass, 12%, my feed, 12%, the water is no solids, the concentrate is 58% solids, my product is 42% solids. The totals, the only thing I know is I want to send in 200 kilograms. The rest of them, no idea what they're going to be. And if I want to calculate the amounts that I have, take the total mass, multiply by the percentage, fill right and down, and then I can count 1, 2, 3, 4, 5 unknowns. How many equations can I set up? Well, I have 2 components and I have 1, 2, 3 unit operations. So I would normally expect 2 times 3 independent equations. Let's see how that turns out. So again, system, unit 1, unit 2, unit 3, and I want my totals, solids and water. I'm going to look at my system. What comes in is the fresh oranges. What goes out? Well, that would be, oh no, I have to remove the picture a bit. Yeah. There we go. Sorry about that. That stream enters my system. What exits? Well, that's my water stream. And it's my product stream. There we go. My unit 1, what comes in is the total of oranges. What goes out would be my bypass and my feed. For my unit 2, what comes in would be my feed. What goes out would be my water and concentrate streams. And for my unit 3, what comes in would be my bypass stream plus my concentrate stream, and it's only my product stream exiting. And again, I can just fill it to the right, and then we have to figure out how many of them are independent. I'm gonna remove my system. I'm gonna remove that one. And for unit 1, same concentrations in all of the streams. I'm only allowed to use one of those 3 equations that I have written for unit 1. So that leaves me with 1, 2, 3, 4, 5 equations, 5 unknowns, 0 degrees of freedom. I can just fire up Solver. And I want one equation and only one of them to be 0. I want all of the others here to be 0. And I want Excel to change all of these lovely values. Solve, Excel found a solution. All of my equations are close to 0. Masses are positive. Does it make sense? Sending in 200. And I'm removing a ton of water and left with about 57 kilograms of product. So that is how you start to treat systems with bypass. Again, I didn't really do anything differently compared to the previous streams. There are more unit operations to keep track of, there's more streams to keep track of, but the principle is the same. I start out with a section where I have all of the different streams in my system. What are the concentrations of the different components? What is either the total mass or the total number of moles that are running in those streams? And whenever there's something where I'm like, I don't know, it's an unknown, I just color it yellow, let's deal with it later. And for all of my components, I can also calculate how much there is. And again, I don't care. So when I started out, I don't care that I don't know what the mass of my bypass stream is. The mass of the solids in my bypass is still gonna be the total mass in my bypass times 12%. At some point, I'm gonna figure out what this value is. And when I do, then this will automatically be calculated and be correct. So let's just solve it again so we have it. There we go. And finally, I have a section where I set up all of my equations and try and keep track of degrees of freedom and all of this. So I think that was it for today. Orange concentrate, do a degree of freedom. We did that. Calculate how much water must be evaporated. We need to calculate the percentage of fresh juice that must be bypassed. Okay, fair enough. So if I want to calculate the percentage that I'm bypassing, so we'll do that here, percentage bypassed. Well, I'm just going to take the mass that I'm bypassing compared to the total mass I'm feeding. So that means I'm bypassing 10%, 9.9. So 10% is being bypassed, the rest goes to the evaporator. So yeah, that's basically it for today. I will chop the stream up into smaller bits and put them up. And I'm gonna put this or these 4 sheets up on It's Learning as well. The ones from the previous 2 days are also up in the folder called Streams, so you can get them there. Yeah, if anyone has any questions, you just write me, email me, It's Learning, whatever, and I'll be happy to help. Tomorrow I'll be online for questions on Zoom from, is it 12 to 2? I think it is. Let me just check. Yeah, 12 to 2. So if you need any more help, you can ask me then. And tomorrow's stream, we're gonna start to move into what happens when we have chemical reactions occurring. So the international class, I know we haven't covered much of it in classes yet, but you are of course welcome to participate and see what's going on, and we'll cover the rest of the theory for these things in the following week. Thank you for watching and see you.